In section 2, we're still going to be solving systems, but this time we're going to use a different method. We're going to use substitution. So by the end of this lesson, you should be able to solve systems of equations by substitution and then analyze special types of systems of equations. So this was in our slides from last time, but remember there's 3 possible solutions that you can get when you solve a system of linear equations. You can get one solution, and remember when we graphed it, that's where they crossed. Today we're not going to graph, but we're going to find an ordered pair that makes both of them true. So we're going to get an x and a y. Our other option is to get infinitely many solutions. This is when the system contains exactly the same line. So remember, you draw it and then you draw the exact same line on top of it on a graph. This time we're going to get something called a true statement. So you'll start solving and you'll get something like 3 equals 3, which we know is true. And then our other possibility is no solutions. This is when the lines are parallel and never cross. And like I've been saying, we're not graphing this time, so we're going to get a false statement. And when you get a false statement, it's going to look something like 3 equals 0, which you know is not true, and that will tell you that you have no solutions. So remember, we have our 3 methods to solve these. We did graphing yesterday, and we're going to do substitution today. We'll do elimination later this week. So here's your steps to solving by substitution. You need to solve one equation for either x or y. And it doesn't matter which one you solve for, but pick one that's easy. So you want one with a coefficient of 1, which means if you're taking a look at some equation and it's like 3x plus y equals 6, it's going to be easiest to get this y by itself because all you have to do is subtract. Where a lot of people want to get the x by itself, but we would have to end up dividing by 3, which makes things messy. Once you've solved one equation for x or y, you need to substitute that into the other equation and solve for the variable that's left over. And then you substitute again your answer this time into the revised equation from step 1 and solve for the other variable. I know this looks like a lot of steps, but we're going to solve, substitute, solve, substitute, solve. So let's do one. So our first step is get either x or y totally by itself. And in this case, they did that for us. We have y totally by itself right here. I know y equals 2x. So then what we're going to do is we're going to substitute this. We're going to plug it into the other equation. And we're going to plug it in where we see y. So I'm going to come here. Everything else stays exactly the same. But instead of writing y, I'm going to write what y equals, which I know is 2x. And now if you look, what we've done is we've turned an equation that had 2 variables into an equation with just 1 variable, and we all know how to solve this. 7x minus 2x gives you 5x. If we divide both sides by 5, we get x equals 3. So remember, our solution is a point. We need an x and a y. So far, we have the x part, but we need to find the y. So this brings us to the other substitute and solve. So I'm going to take this and plug it back into one of my equations. And it doesn't matter which equation you plug it into, but this one's going to be the easiest. So y equals 2 times 3, which is 6, and there's the other part of my point. If I were to graph these 2 lines, this is the point where they would cross at. Let's try another one. So in this one, we have y's by themselves in both of them. So it doesn't really matter which one you pick. Let's pick the one on top just because it's on top. And remember, we are going to substitute this in where we see y. So if y equals negative 4x plus 8, I know right here I have negative 4x plus 8. And just like this says, it's going to equal x plus 7. So all I'm doing is plugging it in. Think if I was to tell you y was 6, you would just replace y with 6 and then start solving. Now I'm telling you y is negative 4x plus 8. And then just like before, everybody knows how to solve something like this. We'll subtract x from both sides and subtract 8 from both sides. So we'll end up with -1 here. And then if we divide both sides by -5, we get x is 1/5. Don't stop here, because remember, you need two parts. You need an x and a y value. So just like every time before, we're going to substitute this in for one of the x's. And it doesn't matter which one you do. I'm going to pick this one right here, because this looks a little easier to me. Y equals my x, which is 1/5, plus 7. Don't go breaking out your calculators. Everybody knows how to add these. Remember, you got to turn 7 into something divided by 5. So we end up with 36/5. And there's our answer. And if we were to graph that, that's exactly where they would cross. Now let's do one that's a little bit harder. Well, this guy right here, if we take a look, nothing is solved for to begin with. But if we look at all of our x's and y's, there's one that doesn't have a coefficient, and it's this guy. That means he is going to be the easiest one to get alone. So all I have to do to get that y by itself is add 6x to both sides. And now I end up with y equals 6x minus 7. So remember, once you have it solved, you're going to substitute. Now this is very important. You cannot substitute it back into the equation you just messed around with. You got to substitute it into the other one. So I'm going to come back up here, and wherever I see y, I'm going to replace it with 6x minus 7. So everything stays the same. The 3, the 2x, the equals 4. But instead of y, I'm going to write what y equals, which is 6x minus 7. And then this turns into a nice simple algebra problem that we need to distribute and combine like terms. So we end up with 20 x's. We'll move the 21 over here. And then we can divide. So if I do 25 divided by 20, that simplifies to 5 goes into 25 5 times and into 24 times. So there's my x. Remember, you need two things here. So let's plug it back in somewhere to find our y. Now what I would do is I would plug it back into this guy right here, because y is already by itself. Y is 6 times 5/4 minus 7. So we get 30/4 minus 7. 7, we got to change to something divided by 4, which is 28/4. When you simplify that, you get 2/4, which is 1/2. So here is where those cross. Let's skip this one. Totally cross it off. I'll never make you go back and do that one. And let's look at some of the weird ones. So remember, we talked about in the beginning, you can get one solution and you get an ordered pair. Those are the ones we've been doing. Now, the next two we're going to do are either going to have infinitely many solutions or no solutions. So let's see how those look a little different. So this first one right here, y is already solved for here, which is awesome. So that means I get to take this and just plug it in right up here. So everything stays the same, except instead of writing y, I'm going to write what y equals, which is 2x plus 3. And then we just got to distribute. So I get 4x minus 4x minus 6, and it equals 8. And then you'll notice something happens here when we go to solve this. 4x minus x totally crosses off. So you end up with -6 equals 8. You no longer have x's, which means you need to ask yourself, is this a true statement or a false statement? And in this case, it's totally false. -6 will never equal 8. So once you get something like this, you need to write that there are no solutions. And you should know in your head that that means that these lines would be parallel. If I were to graph them, they would never cross because they have the same slope. So let's try another one. This one will work out a little different, but just like before, it has the y solved for, so all I'm going to do is take this and plug it in right here. So everything stays the same, except instead of writing y, I'm going to write what y equals, which is -1/2 x plus 5. So I end up with x. When I distribute this, 2 times negative 1/2 gives me negative 1. 2 times 5 gives me 10, and it equals 10. Remember, this has a 1 out front of it too, so if you have 1x minus 1x, just like before, these cancel each other out, but this time I end up with 10 equals 10, which is a very true statement, and because of this, that means I have infinitely many solutions. So I want you guys to try this one on your own right now. Remember your options. You're either going to get one solution, and you need to have a value for x and y. You're going to get a false statement, which means no solutions, or you're going to get a true statement, which means infinitely many solutions. Make sure you write down any questions you have, and we can answer them together in class. Enjoy your night.